Hello, everyone, and welcome to our bi-weekly core protocol sync. We'll be sharing updates on the core protocol side, which includes consensus, networking, and other things from last 2 weeks. And we'll be sharing also updates what we plan to do in the nearest future. And I think it's a great tradition for Shamil to kick us off.
Okay, sure. Last couple of weeks, I finally was able to finish our experimental feature, which is verify block inputs. This feature will allow us in just currently in experimental mode to verify that the blocks that we downloaded through DSN are valid. I also managed to finish an additional feature, which is recover missing pieces through segment reconstruction. It will allow to continue plotting on farmers even if we can't find any piece, some piece on layer 2, our caching layer, or layer 1, our archival storage layer. And I also made small progress on the alternative piece announcements, but I probably will stop doing this feature, and I switch to investigating different issues in our DSN, like stability, performance, connectivity, etc. I'm not sure how long it will take, but this will be my focus on the near future. So that's it.
Yeah, that's the not so fun part that comes after fun part when you implement everything and then you get it into the wild and people start using it and lots of unexpected things happen. All right. Any blockers on your side so far?
No, not yet, except that global blocker of that object mapping, but it's I'm not sure it will be solved in the near future.
Yeah. Okay. Uh, Rahul, why don't you go next?
Yeah, once. Yeah. So in the last 2 weeks, I've been working on the block relay changes. So the proposal went through a couple of iterations, and then now the final design is approved. And I started working on the items. I also created the GitHub list to track the items. The first thing I did was do the benchmarking, and I did the basic benchmarking by creating a couple of VMs, one in New York, one in Frankfurt, and to get the overall latency of how much it takes to download blocks. We found like the smallest blocks take about like 200 milliseconds, and then it starts growing as as the blocks become bigger. For 4 megabyte blocks, we take almost like 2 seconds, 2.5 seconds. But the current focus is mostly on the smaller blocks. So if we can shave the 200 seconds to the minimum latency, which is like 100 milliseconds, that'll be great. So that is our immediate goal. After that, I started working on the creating the alternate block relay path, as we discussed in the block proposal. So I have the basic coding done, and I started testing it like last few days. So basically what we're doing is like we create our own gossip channel to send the block announcements, and when a block announcement is received, we use the request response protocol to uh, request the block downloads. So that's where I'm at right now. I'm running into an issue where the RR doesn't go out. So the libp2p seems to silently return error. It doesn't give a error code or anything. It just returns like an empty error, and I'm trying to figure out why it's not going out. So I have some leads. Like I know like which path it's hitting, but I'm like basically he tries to write into the substream he creates one substream for every request that you send, and then he tries to write to that, but it returns an error. So I know where it's happening, but I don't know why it's happening. So that's what I've been trying to look into the last couple of days.
Are you saying that the P2P just returns parentheses as error?
Yeah, so the libp2p, so the substrate calls into libp2p to send out the request, at which point the libp2p actually does the codec deserialization and tries to write into into the stream. That seems to work actually. I added some logs in that path where he's able to write to the stream and also read back from the stream, but it doesn't actually go to the peer, which is pretty mysterious. I don't know why it's not going into the peer. So my suspicion is like the stream just deposits into something, but somehow it doesn't go out. And libp2p is not
Maybe
very well.
just handled locally.
Hmm?
And if it cannot be handled locally, then it goes to the peer. It happens like that in some cases, like get value. It will try to get value from local store, and then it will go to the peer if there is
Oh
none.
no! In this case, like it doesn't even know what it is. Like we are just saying like send a request message at this point. So basically, I get a block announcement, right? So what the block relay does is it creates a request and serializes that and just says right. It doesn't actually tell fetch a block or anything like that.
You should still like register the protocol, right?
Yes,
You register a list of
yeah,
protocols you support.
yes. I did have some initial issues where the protocol was not properly registered. Now it's registered, and I also verified like the RR config that we create. It's exactly the same as like for the block relay, the existing block relay, and the state sync and the transaction sync and everything. They all look the same, but I can't tell why this is behaving differently compared to the ones which come up by default. If you have any ideas, yeah, ping me
Is
out.
it just 2 nodes locally, right? It's not connecting to the network
What do you
outside
mean?
of your machine. You have just 2 nodes locally, right? Talking to
Yes,
each
yes,
other.
2 nodes, yes.
Interesting.
So hopefully by today I'll be able to resolve it. This is like a blocker. Once I get past this, I should be able to do end-to-end testing. So right now we get a block announcement and send a request, which is not happening. When the request goes out, I am the next step would be to hook up this implementation to the actual block backend and serve blocks. So that would be next step once I get past this.
Okay, so basically re-implement what we have, but outside of Substrate, kind of.
Yeah. So I have
requests.
draft PR. Maybe I'll share it like when end of the day. Right now it has a lot of debug. That's why I'm kind of holding off on that. Maybe I'll send it out by today or something.
Okay, if you feel like you hit a wall, just let me and Shamil know. We might be able to help with
Yeah,
that.
sure. Okay, thanks.
All right, let me share my screen. I have quite a few updates again. Should be this one, I think. Yeah, okay. Let me do it like this. Should be right proportions. Okay, so from last 2 weeks, one thing that was interesting and eventful was Substrate upgrade. Basically, they broke support for Windows, and they didn't notice because they don't run anything in Windows in CI. So we had to fix a few things, and then eventually we narrowed it down to a problem which wasn't Windows. It was related to WASMI. We were still using that in some of the tests, and Lucheng just changed that as suggested by Basti to use WASM time, I believe. And that compiled and finally merged, but it was open for like over a week, I believe. So
Hey,
that was interesting.
I have one
Yeah, go
question
ahead.
here. So debugging that issue, I had to create this temporary forks, and I patched our code to point to that code, right? One issue I'm running into is like the substrate that we are currently using, uh, Subspace V3, I think, right? It uses like libp2p 5.0, but the Subspace core itself uses libp2p 5.1. So,
It's 051, but
oh,
yes.
sorry, 051, and but the subspace substrate we are using uses 0.50. So,
It's just upstream Substrate. I don't believe they upgraded to 51 yet, but we are making some changes on top, and we would rather build on top of the up-to-date version so we can submit a pull request upstream. That's why we have a newer version there, but we still have an older version in other place. Quite often they are the same, but sometimes Substrate just isn't able to keep up at the same rate, so they diverge from time to time. Yeah.
okay.
But yes, that means that we compile two versions of some crates, which impact CI and build size and everything, which is unfortunate.
Yeah, I found it kind of surprising. Like we have two different versions of the same crate
Yeah.
in Canary.
Yeah.
Okay.
It's even weirder, like in SDK, because like you have to convert like same types between two like.
We have that in one place on the node, I believe, as well. Yeah.
Like I have
And
that
the error
all
message
over.
is not super helpful.
Yeah,
Like you wanted PRID, you get PRID. Like, what's the problem?
true. I did that just like converting to string and back. Yeah.
Yeah. Okay. That was Substrate upgrade. Then there was this older version of the pull request that was implementing incremental record commitments, and there are some references for the issue and the pull request and what was the problem. Basically, the problem was, as a reminder, that when we are building a segment, in the process of building that, we are increasing number of segment items in the segment, and then compact length encoding of the number of items can change in byte size from 1 to 2 bytes and further. And that was causing our incremental building to be actually not correct because everything was shifted at some point by 1 byte. So much for incremental commitments. I have changed a little bit the way our segment encoding in archiver works in general. There is a description, but basic idea is that we do not have length prefix anymore. What that means is that when we are building segments, we just concatenate essentially segment item after segment item. Why we can do that? Because we know the data structure and we know the size of the segment itself. So once we have the whole segment, we can just read one by one until we hit the end of the segment. Segment, as a reminder, can like all of the segment items serialized together may not actually hit the boundary of the segment. So we are padding that with 0 bytes. And in order to handle that, we have a new padding enum variant or for segment item. It basically serializes to 0. So that's how we cover those like 1, 2 bytes at the very end. Otherwise, it's mostly mechanical changes. And it allows us to basically build the segment start to end in incremental fashion while it never shifts and the beginning never changes. In the previous iteration, I had to account for the fact that the beginning might change with the length update. Now it doesn't change, so it's much easier. So implementation should be better. So this pull request just changes the way segments are serialized, and that's basically it. And the next pull request after that is rebase basically of that old version, which with simplifications and better comments, which does the actual incremental record commitment. And that is what we have on the main branch. I hope quick description makes sense. You can go through comments if you'd like. Any questions about this one? All right. So these two. These are just some tweaks on top of Shamil's pull requests. I think I can go into this one, just show one thing. Rahul, you're not. Yeah, let me open this one. So basically, when I'm reading code, I read it commit by commit, and I'm also reading it top to bottom. And ideally, it would be explained like a story, like what you are trying to do. I just want to find one example where that was really kind of obvious, and show that to you. Yeah, I think this one is a pretty good example. So basically what was happening before, it was actually like correct, it was working. We were trying to find what is the start piece index in a range that we are trying to get. And then we were taking that start, we were creating a vector with the collection of indices that we want to get from the network. Then we create some supplementary variables. Then we go through all of those indices, iterating. And for every single one, we are taking the semaphore. And so we don't make too many parallel requests. And after that, I think there should be some more code in here. It doesn't quite make sense. Yeah. So if we hit enough entries, like we do not we're not able to acquire it anymore, then we just return none here. Otherwise, we are going through the process, and that process is to get the piece from the network. Then we need to, then we need to basically store it. So we return the piece, we collect all of that, and we basically here we are reading all of those responses. So this is kind of asynchronous. So it may or may not happen. At this point, we are actually turning that into a stream, and we are waiting for one at a time. So we are not actually doing anything in parallel in this case. Then we also have the pieces which are just like a placeholder where we will store results. So we get one piece from here and we store in this vector, right? And then we are going through those pieces and we are counting whether we have enough of those pieces, which are some which we were able to download from the network, because we need at least half to reconstruct the segment. And then once we have that, we can actually create an archiver. We can feed all of those pieces into archiver and can get our block and import it. So kind of makes sense. It like does what it's supposed to do. But if you're like really top to bottom, there's a lot of jumping back and forth, and it doesn't quite feel like the straightforward thing. So turns out we don't actually need this arc. We can just acquire non-owned semaphore. And then also in terms of the piece download, we don't need to collect it into vector. First of all, we can just iterate it directly. And then since we are taking the piece from here, and then in the loop here, we are reading that and doing something about it, we can kind of do everything at once. So instead of doing that separately, we are iterating over our pieces. We are turning every entry, which is just a piece index, into a future. That future will try to get the semaphore, return none as usual. Then it will increase counter how many things we are, how many semaphores we are holding right now. And then we are trying to get the piece from the network. We are not doing any retries. And after that, we will, if that piece actually is found, we will return it. So we will actually store the counter right away because we had that counter before. We don't need to iterate for some later. And then once we've processed that, we can just collect it into ordered future. It was unordered before. That's why we had to have these pieces, and we had to find an entry at which we need to insert, which again introduces here, for instance, a check at compile time that entry exists. Otherwise, it will panic. Here we can just collect it into ordered future because we want order, and then we can collect it into vector of options because that's what we want, and we can wait. So all of that basically simplifies to a single iterator. It does the same thing. There was nothing technically wrong with what it was before, but it is kind of the straightforward thing that we want to do. So like, what do we want to do? We want to go through all of the indices in this segment. We want to download at least half of them, or like at most half of them. And for everyone, we just get it from the network, check if it's some, and collect into the vector. Like you can kind of tell what you want to do, and that's what the code represents. Otherwise you need to like jump and in the mind to like need to build a graph of what's happening. So just like thinking a little bit about it, simplifying things further and further, you can kind of come up with this a little bit more concise version of the code, and it is like more idiomatic. If you feel like sometimes that there should be a thing, like there should be a way to take all of this stuff and collect it into vector, there probably is. Like Ivan is the best in these things. Like he suggests us what can be done all the time. I don't know all of those APIs, but there are quite a few fancy APIs like this where you can just collect a bunch of futures and you get a vector out of it. You don't need to worry about anything. It's quite great. And this can be like also a result of a vector of an option of a piece. If you have some error handling, you can just question mark it and it will bubble up. So this is just like one of the simplifications that are possible. Go ahead.
Yeah, I just want to say that like it's quite quirky if you want to do like that question mark thing with collect for streams, because like you can do that, I believe. Like you need to like to use try collect or something. Yeah.
Maybe. Okay. So that much for the pull requests which are resolved. There is one which is open. I mentioned it on the DevSync. Basically, this is an alternative implementation of the ratio coding that uses library Rust KZG, I believe. It is in the pull request. I'm still using the older version here. We need this version which uses BLST library and everything else is Rust. And this is just some types which are generic for different implementations. This repository has like 5 of different implementations. This is the most like canonical and maintained one. And then we basically have ratio coding data structure where we can create it for a certain scale. That scale basically is taken to the 2 to the power of scale. That's how many entries we can store. It allows us to not have some checks in the runtime. And then we can basically extend this thing with some data. So we get parities. And then once we have data and parities which are incomplete, we can put shards in and get shards out, but they will be interleaved in both cases. That's how library works internally. And we discussed with Daria a few times, and we decided that if it's the way it is, and our plotter side will actually use interleave data as well, we decided to just leave it as is. We can convert it outside if necessary in some cases. So it's quite straightforward. There are some basic tests for error cases and happy paths. In order to make it happen, I had to do quite a bit of work upstream. Basically, there is a bunch of not assigned, closed, a bunch of pull requests into Rust KZG library that were quite welcoming, like 1, 2, 3, 4, 5 pull requests, starting from dependencies not installing due to yanked crates, to not compiling, to not being idiomatic, to not compiling for WASM. All of those are done and work, which is great. And all of those were actually already merged into master branch that they have. So I'll switch to upstream fork from our own. What wasn't that fun is Supranational's BST library. I have a pull request here that basically implements noisy support that wasn't before. It was still compiling for WASM, but technically it was not noisy supported. So it might crash in runtime or may not compile for some other targets. And the biggest challenge is it seems like Andy wants to have this intentionally non-idiomatic in Rust. So he's doing some interesting things in the alternative pull request in here that I don't quite agree with, and it's incomplete. It just takes a whole bunch of APIs and just makes them unavailable instead of making them available for some reason. So I'm not sure what's up with that and whether we can do something about it going forward. But that's what we have so far, and I'll try to push this forward if possible. But this is one pull request, and I believe there was another one. Yeah, and yeah, actually. And this pull request is related to Chia. I was working on the C++ code base that they have, reference implementation, and trying to expose that as a library so we can use it in Rust for the consensus purposes. So this just one thing I found. They had a global variable that was that it didn't have to be like it was necessary for it to be global. It could have been shared. That's a simple thing. The important thing is that we have a fork of this where I'm working on some stuff. I can show you the branch. Basically, it takes what the implementation that they had and it refactors that to remove some legacy stuff. They have this B17 stuff, which I believe is beta 17, like older version of the plotting, and they also had everything working with disk. So I replaced those on disk implementations with in memory. So it basically, instead of a file, it uses a vector, and with that, a lot of things were then simplified, removed, and eventually we have something like this, where we have an API which is specific to Subspace. This is not the latest one, but you kind of get the idea. The way you use it is you create a table which will allocate on the heap some stuff for the case size that you want. In our case, it's 17 because 16 doesn't work for some reason, and a seed, which will be unique for every plot. And then we create a prover for that, just another abstraction. And then using those two, we can issue challenges. with indices from 0 onwards. And if there is a proof, we will generate that proof, and we can then verify that proof as well. So I'm working right now on exposing this as a Rust crate. And with that and erasure coding, we should have most of the primitives necessary for actually building Consensus 2.3. I think one other thing would be to change the KZG library that we are using for commitments to use the same library as we are using for erasure coding. But outside of that, it should be pretty much sufficient for the actual like business logic that we have in the consensus. I'm not a C++ expert. I didn't enjoy it. It seems to compile. There was one interesting issue that I found with undefined behavior. So basically what happens is they were allocating a buffer into which they were reading stuff from disk, and then they were slicing that buffer. In this particular case, when it was happening, it was 5 bytes chunks. That was like the intended length that they care about, 5 bytes. And they were like swapping bytes in between and doing some other stuff. And they were calling for those purposes 8 bytes to int function. And they were just providing an offset to the beginning of those length bytes that they care about, and then they were swapping bytes around, and then they were taking only some of them. So they were not actually like, they didn't care about bytes outside of this, but they technically read it. So what happened when I changed to the in-memory implementation, I didn't have that buffer. It was not necessary. But when we hit the end of our table, it happens to be the case that we are reading 8 bytes in here, even though we are supposed to only read 5. And when I ran it on the while grind, it was complaining. So I had to create a stack variable where I'm reading up to that many bytes, which are very smaller. And then I'm using that. Like, it's just like C++ stuff. It was like accidentally working, just pure coincidence, in my opinion. So I had to fix that. That was one interesting thing I found in the implementation. I feel like the reason why it doesn't work with the K below 17 is some other coincidence like that. It just like happens to work with bigger K, but doesn't work with a smaller K. And we would really like to have K16 because it is twice as fast. But it's not a big blocker for us right now. So kind of rolling with what we have. I'll probably send this for Rahul to take a look. Maybe like a quick glance if something is completely stupid. Yeah, but otherwise, that's what we'll probably use to start with. And we actually like don't need about half of it, but it is more work to delete that half. So I think there is a lot of opportunity for optimizations and simplification still left. But yeah, I guess that's all I want to share so far. Any questions?
Will we be making these changes upstream as well? Is that the plan?
No, they are not upstreamable. I mean, technically we could, but for that we would have to use memory mapped operations with files, and they already have that BladeBit, I believe, implementation that is kind of the fastest, and it works in memory. It works with disk. It's super amazing, and this is left like an artifact just reference implementation. So I don't think they care about it. BladeBit. Why we cannot use this one is it is intentionally K32 only, and I have no idea how much we would have to modify to actually make it compatible with other things. And it seems to be a little bit more complex. It supports GPUs, I believe. Maybe it doesn't. Regardless, like we just decided to get something working, and then we can move from there. Yeah.
Cool.
Any other questions, concerns? All right, so this week I will be finishing this Chia proof of space adapter into Rust, and we'll start moving from there with the rest of the version 2.3 consensus. All right, I think that's it for me. Ivan, do you have anything to share?
Like not necessarily, I guess. Like I started working on that PR. I mean, on that issue which you sent me over, like that long-standing issue on the PyRTDB side about optimization of memory usage. So I started looking into that. Yeah. Also, like how to say it, rework the code base a bit because like it wasn't very like in very Rust way. So I will publish that like soon, I guess, this week. Yeah, also started looking into ways to optimize memory, and it seems like there is an API from the like at least on Linux there is an API for syncing some memory pages. So like that would allow like on the PyRTB side that would allow us to remove some caches and just like simplify implementation like a lot because we won't need to cache like lots of things twice. Yeah, we can just use the like caches and buffers from operating system and just call the
Just hint to the operating system, please cache this like piece of file or whatever.
you don't even need to like I believe it should cache like for memory map files. It can cache everything until the point when you call the memory map sync msync system call. So you just supply the region which you want to sync to the disk, and only after that, the operating system like guarantees you to that like but all the changes were actually written to the disk. So like you don't even have to like tell anything, I believe, but I'm not sure.
Yeah, I think Parity guys would be really happy about that. But in our case, we would like to support Windows and macOS as well. And ideally, it wouldn't be terribly slow there. Otherwise, user experience would suffer. So, yeah.
I will look into that. Just that like I use Linux as a reference for now. Like yeah, I didn't know. At least the like memmap2 library for Rust, which is used for memory map files. It supports like that API, and it's like
Yeah,
system agnostic.
okay.
So yeah,
Yeah.
everything's good. I believe.
Yeah. Otherwise, like you wouldn't be able to just simplify that thing. You would add even more complexity, which is not amazing. I was actually thinking about that, and I think there is an opportunity for the sync speed improvements using some of those tricks. So I was thinking that if we are syncing from the network, and we know that we will be executing a lot of blocks, and some of those blocks will add some stuff to the state, some of those will be deleting stuff from the state, and if we have pruning enabled, so we don't even care about the whole set of state changes since Genesis, what we can do, we can actually save it to disk either like every 1,000 blocks or 2,000 blocks or like towards the very end, such that you don't have to do disk writes all the time. You can, if you have enough memory, and operating system can cache it, we can potentially do a lot of block execution in memory completely without touching disk. That is especially important when you are restarting from scratch for whatever reason or something like that, because there is a lot of disk write amplifications, and that issue actually was closed as kind of idling on ParityDB side. I can probably find it quickly. That was a little bit concerning. ParityDB.
I believe on Subspace side there is like two ways of pruning, right? There's state pruning and there's block pruning.
There are just two different things.
Okay.
So this is the pull request I'm talking about. 181 on the ParityDB side. Basically, there was a user that was complaining that it seems to use too much resources on disk, like reads and writes, writes especially during sync, I believe. And yeah, it was like 10x something amplification factor, and it was close, like due to inactivity, and it kind of supposed to be that way. But if you can skip at least some of that, I think that would be helpful. Of course, we would have a like client eventually, but still feels like a decent improvement potentially.
True.
Okay, thanks, Ivan. I think that's all we have to share this week, and we'll see you all in 2 weeks with even more updates on the core protocol side. Thanks.